Is supported on the board and what type of panel. So I'm going to show you my graphical user interface, and after running, this is our fig file, and as you can see there are two panels, one for the slider control which has all the three joints, joint 1, 2 and 3, then effector positions in XYZ, and we have four push buttons, and when plot robot is basically where the robot is plotted in the XYZ plane in this axis, and initial position is where we set a specific position for each joint angle to follow, and loading the image is where we load the image in this axis and we trace the aspects of this image here, and this connect button is basically to end the connection between hardware and software, in this case our MATLAB and Arduino. This is where the trace point, this is my trace points before applying inverse kinematics, and this is after applying inverse kinematics to my trace points, and this will basically what the robot will draw. So let's start by plotting the robot, setting it to an initial position, loading the image. Now I'm going to trace some aspect of the image here. Let's say we make a square here. Now this will okay, so the robot stopped has finished plotting the square, and I mean it's a bit different after icon, but it's almost, I mean it has four corners, which means, I mean, it has done a pretty good job. And to show you here, so we have the, okay, yeah, so these are joint angles computed by inverse after IK and this counter basically is zeros. This means that, you know, there were no empty joint angles returned. That's the reason why the counter is 0. And one more thing to notice is, you can see, so this is in joint 1, joint 2 and joint 3, and joint 3 is always constant. The reason for that is, like, even though we have a 3 link planar robot, we have only 2 degrees of freedom. So basically the last joint is just going up and down. It doesn't have any variable theta values.